Alright, another draft physics presentation. Kind of on magnetism. That's where I really want to go. But I'm probably going to go there trying to... It's like one thing to understand something, it's another thing to explain what you understand. And you really can't understand magnetism without understanding everything that goes before it, so to speak. So I'm going to start with what goes before it. Start from the beginning as if I'm explaining it for the first time to somebody who hasn't already heard this. So this will be a video with some redundancy in it. But it's like, again, for my own purposes, to make my own, to be able to present it in a way that people can understand. So you have to start from the beginning, then you understand that we're in a universe and we have this stuff we see that's physical and real stuff, like a pen, matter. And then we have an idea that there's something that makes it move. And most people call that some kind of force. And in sophisticated physics, what the physicists are doing, this isn't really a force, it's some sort of mathematical thing. It's just an idea of a mechanism that's somewhere in here, this field of some kind, and this field of mathematics dictates that there's certain rules about motion. And so the first argument I would make is that there is no fields. There's no ether, everything's not existing in some other universe of stuff. We're not waves in water. We're individual bits. We're molecules of water. And we can be waved, but we don't wave. Something has to push us. As a water molecule, and there's a wave coming, as a water molecule, I'm not going to be moved by some field or some invisible force. I'm going to be moved because another molecule is going to hit me and it's going to push me, so to speak. It's going to transfer its attitude, which is move, and it's going to transfer it to me by getting close enough to me where I'm going to feel or be persuaded by the material interaction to move. And so it's just understanding what allows material things to tell other material things you got to move. And there's a force involved, but it's not a field. It's not something under the universe. It's a real thing. It's another thing that's just a smaller thing. So we have two things in the universe. Material things that tend to be big, and the force things, which are really small. So that would be like light or something like that. It's a force. It's not matter. It's a kind of thing that's really small, and it can come in waves, in the sense that, just like water, it could be a bunch of water molecules and they can push each other, so to speak. Although that doesn't happen. But anyway. So that's really the whole thing comes down to, is understanding that there's stuff we could call the little bits. And let's do them in some kind of stark colors, just to make it obvious, of black and red. And then we have, and that's all in the universe. It's full of that stuff, and then that stuff can become something material. And so the material stuff I'll do in blue, and it's a bunch of that stuff inside of it. So it has a bunch of force, little bits that make it up. And you can't see the little bits. They're in a different state. They're not free. So you could think of these as being free, in the sense that every one of these little bits is just going the speed of light in its direction, and that's all it does. It does one thing. It just moves in a straight line the speed of light, and that's a force bit, F bit. And this stuff, although it's made of this stuff going the speed of light, it's made of stuff going in all the directions. So it doesn't have any innate directionality. It seeks balance, so to speak. It's kind of forced into it as being the preferential condition. But it can have, these force bits can interact with it and give it a bias in a direction. So it can move something much slower than the speed of light, less than c, much less, and this is called a matter bit. And the matter bits we understand to be fundamentally made of protons and electrons, and they're little bits, but they're a lot bigger than force bits, and they have, in essence, they're one kind. So one is all red and the other is all black inside, let's say. Just trying to keep it. This is how it all starts, and this is what we call charge, is this difference, because how these bits will interact with different colors is the definition of how everything in the range of what we call force functions. So you have matter bits and you have force bits. So these are the matter bits. These are constituents of material things, electrons, protons, and neutrons will include, but I would argue that neutrons are just electrons and protons stuck together. So a neutron really is just a combination of a proton and an electron. So it's not terribly relevant to understanding the basic mechanism, because a neutron is just a combination of the two. So its function will be dictated by what it's made out of. So this thing is said to have a positive charge, the proton, and the electron is said to have a negative charge, and the neutron is said to be neutral, and its neutrality is just a byproduct of it has both the positive and the negative. This one I said was negative, and this one is positive. So this just has to do with, it's only important in the sense that having a different charge means you interact differently with the force bits that come in these two varieties, black and red. Identical in every respect, except they're just different in one respect, and that's a charge respect, you could argue. Alright, so everything we call a force, like something invisible that makes things move, okay, so that would be like light and magnetism and the nuclear forces that hold atoms together. All those things are just this in different forms. So light would be these bits at a frequency, and it's just it just happens to be that it's just the black ones, because they just affect electrons. So a photon is just black bits coming at a consistent period, and that we call a visible photon of some kind, or any kind of photon on the electromagnetic spectrum. So there's nothing electrical or magnetic about them. It's just that it's a force bit at a frequency, and that affects electrons in a specific way. I should have made electrons black, but it doesn't. You'll probably be able to follow along. Now magnetism is going to do something different, and it's going to be these little force bits, but in a sense they're just going to be, the magnet's going to produce them in a very segregated way. So the force bits will come in we traditionally think of a magnet as having the two poles, and what's going to happen is the force bits will come in to the magnet from the external world completely mixed, because that's what the external world is doing. Oh, I should have added gravity here. Yeah, it's quite sort of an important one also. So these are all forces. They're not spent space. It's not some electric and magnetic fieldy thing. It's not some Higgs boson field. No, these are real things that make things move. Nothing moves because a field moved or a field was vibrated. It moves because real bits, like real molecules of water, are moved because physically the stuff next to them forces them to. They're forced to move by a force that's made of something real, not something fieldy, not something in some sea. They're real molecules hitting real molecules. It's real physical things hitting real physical things, interacting with them. And I mean physical in the sense that we can quantize them. No, what it's really made out of is sort of irrelevant. There's just a distinction between nothing and something. So these are something separated by nothing. And when they're a photon, they're something with a separation of nothing, and then another photon, and then nothing, another bit. We count this as a photon, the frequency. So you have to have two of them as a minimum to detect it. And we call that a photon, but technically it's made out of at least two force bits. So anyway, back to the magnet as the example. So the energy comes in from the external world, mixed, non-segregated, as I would say, and it comes out of the magnet segregated. That is, just red comes out. So the force goes in and it gets converted by the magnet so that only black comes out of the black end, only black little bits moving the speed of light, and only red little bits come out of the red end also moving the speed of light. So it's just a filter. So that's what you can understand a magnet as a filter. So all it's doing is filtering energy. It's not creating energy. And so the fact that there's a very different reaction that electrons will have to one side of the magnet than the other side of the magnet is this charge circumstance, and that's why the magnets will repel and attract, which I'll get into deeper as I expand this context. So the other force is gravity, and it kind of simplifies a magnet in the sense, so magnetism is segregated force, filtered. Light is at a frequency and segregated in the sense it's only one kind of force. And then gravity is like magnetism in the sense this external stuff is what's hitting it. So there's this energy coming from the external world, like the cosmic background radiation, except there's more of it that we're not seeing. Can't see these particles because they don't come at a frequency. They don't do things that make it obvious. We can only see them indirectly. We can only see them in how they affect matter. So in a sense we do see their effects, much like we see with our eyes, because electrons are stimulated by the photons hitting them. The photons hit the electrons move, and that movement is amplified by our physics of our body and turned into a signal that says photons hit an electron. And we watch planets move into each other. So it's not a magical force that's causing that. There's all this field energy that's always bombarding things. And when they're separated by distance, then they're bombarded from all sides evenly. And that's why they have a round shape. It's because the pressure is even from all directions. But as they move close to each other, as they're put in proximity to each other, what happens is they absorb more energy in the direction from which more force is going through them. So as force goes through them, it can be captured, and it's captured based on how uneven it is. So if there's more arrows coming from one direction than this other direction in terms of pressure, the object will absorb more from this direction, and it will release more going the opposite way, and therefore it will acquire velocity in the direction of the low pressure. So you can sort of understand that if, as things move towards each other, as this body moves towards this body, what it's really doing to move, so it's going to move this way, what it's really doing when it moves is it's absorbing energy going this way, and it's releasing energy going this way. So it, well, technically this way or this way also. And that's why it moves. And so that movement means that it absorbed a piece of pressure that would have hit this. So to move, it absorbs pressure. That means the pressure doesn't hit something else. So it's like somebody punches me and hits my nose. That stops them from hitting my brain. So yeah, they make a mess out of my nose, but they don't hurt my brain at all because my nose was in the way. And the same kind of thing's happening in this pressure equation. So as this object moves towards another object, it absorbs force to do that. And that means less energy hits this on this side, and so it absorbs energy going this way, and so it moves towards the other object. And by moving towards the other object, this object doesn't get hit by pressure, so it moves towards this object. So they just induce low pressure between each other as they move towards each other. So as they move towards each other, they're absorbing the pressure, and by absorbing it, that means it doesn't hit the other guy. So if I move this pen closer, you can sort of think that the pen absorbed energy going that way to move, and by absorbing it, this pen doesn't get hit by it here, and so the external pressure pushes it in the sense that it absorbs more external pressure going this way, and they just keep doing that until they crash into each other. So that's gravity. So this same force explains everything: gravity, light, magnetism, and these nuclear forces, which I could go to the website and explain, but I'll draw another picture of it here. I have images there of this concept. So the idea is electrons and protons are in this field, just like the planets are in the field, the magnets are in the field, and because they're doing a specific thing and reacting to the field, they have a certain function. So gravity is mixed polarization and no consistent frequency. I mean, if it came at a frequency, it would just make it more effective, but it just doesn't. So it just doesn't matter. And the pressure is, generally speaking, even, and what creates unevennesses in the pressure is proximity. So as things get closer to each other, they create unevennesses. Now the same thing's happening on the nuclear scale, where yeah, go it this way, where protons and electrons are interacting with each other. And so there's a simple rule about their basic function in terms of this little bits of energy. So the rule is that if a red bit, hits a red thing, it bounces off and just goes back, and then it bounces off and just goes back and forth, back and forth. So if there's two electrons, and these are the red bits are the electron bits, then they'll just bounce back and forth. And you can sort of understand, as the two electrons got closer to each other, the amount of force would increase because the amount of impacts is increasing. So as I'm getting closer, it's like if something's punching me, that's going to punch me more and more often the closer the shorter the arm gets in terms of the swing of the pendulum, so to speak, the more hits you get. And the same thing's happening between electrons. And the same thing is the protons are doing the same thing, except the opposite bits. So when the opposite bits are between the two and you bring them closer, you'll increase the number of impacts, whatever's trapped between them. Now you can have a circumstance where whatever's between them is removed, and then they can be very close to each other. But that requires a circumstance where something bleeds the energy out. And so the trick is that electrons bleed the force that comes out of protons, so that when black force is coming off of a proton, let's say, and it hits an electron, it leaves the electron going perpendicular. So one of the 4 directions on that plane. The two the two dimensions that the force isn't moving in is the direction where the force will be released. So it's like a relief valve. There's no pressure created because anything that's trapped between an electron and a proton, the black stuff will all leak out of the electron and the red stuff will leak out of the proton. So nothing can get trapped between an electron and a proton. So you can understand that if there's external pressure and they're in proximity to each other, that the external pressure would be high pressure, and that the internal pressure would get low, because there'd be very little that could get trapped between here reflecting back and forth, so it all leaks out. And so they'll tend to move into each other because all the repulsive pressure is absent. So that's what makes it possible to have some arrangement of electrons and protons, where you could actually have 2 electrons on one side and you could have a proton in the middle, and theoretically these 2 electrons would have a certain level of repulsion to each other, but you could get them closer to each other by having a proton in between, because the force that would have reflected between them is instead released. It goes out of the proton. So all this force is negated and you end up creating low pressure again between them. And so now the 2 electrons can be much closer to each other because the proton's in between them. And that's sort of what holds atoms together, is that arrangement where electrons are held tight to each other across the proton, where they hate each other going this way. So if you had 4 electrons circling a proton, so to speak, or encircling, they don't really circle, they just encircle. Big difference between circling and encircling. Okay. So they still have high pressure between each other this way, but they can have very low pressure between each other this way. So they have a lot of pulling attraction going in and resistance to movement towards each other. So you can sort of understand that this electron wants to go towards the proton because there's no pressure, but at the same time these 2 electrons are pushing it away. So it has a balance of pressure between the 2, and you can understand that that's essentially could be considered a spring, so that when force bits, extra ones might push this electron, those force bits would be unsuccessful because the electron could spring back. And so that's the nature of what creates frequencies and waves in atoms, is the fact that all of their structure is under tension. There's a balance between the forces of repulsion and the forces of attraction. One doesn't get stronger than the other, and so the atom holds a general condition that's always in tension and is likely always vibrating a little, just from the environmental inconsistencies, little subtle changes that happen in the environment, and those changes just vibrate through the mechanism without any friction. There's nothing else to lose here, so it doesn't slow down, or any kind of hit just keeps moving through it until something happens to get rid of the hit, so to speak. It has to, any energy in, it's stuck with until it's energy out. There's no heat or friction or rubbing or some other thing that you could dissipate and it would go away. So all of these movements by these little bits are permanent, and anytime a bit goes in, it's going to create change until it goes out. Yeah, so that's the background, and the biggest point is that you just have to recognize that you just try to view force. So this is essentially the nuclear force I was describing here. But all the things that make the matter bits move are these force bits, and the force bits are changed by the filters they travel through, and the filters are basically made out of the arrangement of these nuclear pieces. And so the all material movement can be understood as just being this energy in these different forms, where you have it at a frequency, you have it segregated or polarized, and that you have it in a condition where it's universally applied, but proximity is still going to create an imbalance, and any movement is going to have to be created by absorption. Nothing really can move unless it technically and physically and actually absorbs the force. So if there was two schools of fish, one moving and one stationary, what's really going to happen if one bangs into the other and made it move would be exchanging the fish that were moving this way. So this one has more fish moving this way. That's why it's moving this way. And if it hits this school, which doesn't have an imbalance, it's just staying right here, then what's really going to happen is this school of fish is going to exchange with this one, and it's going to give this school of fish going this way, and it's going to take fish going this way. So this one will stop moving because now it has a balance of fish going both ways, and this one will start moving because it accepted the new fish going the new direction, and it got rid of fish going the wrong way. And it's really that simple. Yeah, really. It seems too simple, but it's not, because that's really the function. The function only has these small number of rules about the interactions between these red pieces of matter and black pieces of matter, and force bits that are red and black. And as pointed out, these subtle differences in how they interact creates all the phenomenon we consider to be force and motion and energy. Alright, so to get to the specifics of magnetism. So a magnet is, as pointed out, a filter, and this is a rough diagram of that phenomenon, in the sense the force comes in and it gets segregated so it all comes out one end, and then segregation happens through the arrangement of these electrons and protons. And the argument is, even in conventional physics, it's sort of accepted that the imbalance in the positions of them, their magnetic moment, if you want to call it, the idea would be is that when an electron's in a certain position to the proton, this has a magnetic function, in the sense that one end is weighted electron, one end is weighted proton. So one end is a red most of the time, and one end is black most of the time, or some significant amount of time. The conventional model has, matter is made of this nuclear bit, the nucleus, the protons and the neutrons, and a bunch of these electrons are flying around the outside, and spinning about, going around and around. I would argue that they're not doing any of that, that they're in fixed positions, and that the only movement they do is vibrations back and forth and in and out. So they're in tension with each other. And so when an electron is, when they talk about an electron being shared by two atoms, so there's another nucleus over here, and it's protons, and it's got its own electrons, but it only has, it only has three. They're in fixed positions, and they're sharing this fourth one, and they're really sharing it, in that this electron isn't flying all over the place. They're really sharing it, in the sense that there's tension, real tension, between this electron and this electron, this electron and this electron, this electron and this electron. It's real tension, and that's what holds the atom together. I don't think there's a practical way to have electrons rapidly spinning around a nucleus and at the same time maintaining tension with other atoms in any significant way, because the atoms would just separate every time the electron moved through its spiral. This atom would disappear. It wouldn't be enough of a glue to hold things together. So I don't think the standard model is the correct model. I don't like having to challenge that, and I don't, it's not necessary for me to do it to defend this theory, but I think it's also an incorrect answer. So, I mean, none of the answers physics has for most of these fundamental elements, the fundamental axioms of physics, bent space, quantum woo, I don't know what else to call it, and this idea of a model of the atom that has all this motion in it. I think those are just all fundamentally wrong guesses, and they're not a good foundation for getting the right answer. But anyway, all right, back to the real story. So this is a diagram of just the basic point that black stuff goes in, it comes out this black side, red stuff comes in this side, it comes out red. And so just about the transfer of directionality, and so the basic segregation. And it starts with the electron and proton creating the filter, in the sense that if they keep arranging in that way, you know, a proton, electron, gotta switch colors, proton, electron, proton, electron. So you can just imagine they would keep lining up in a manner that would keep creating this circumstance. So we know that electrons can get closer to protons, so you'd have an electron here, and then you'd have a proton next to this electron, and then you have an electron next to this proton, and then you have a proton next to this electron. And when matter can do this, when it can do this really staggered, oops, wrong color, it's got a, it's a simple pattern, but it's easy to mess it up. You know, but that's so the more matter can look like this, the more atoms are in a configuration where all of their where they can be as tight and as efficient in their connection to each other, and create the strongest and most, you know, the most consistent bonds between each other. Like all these distances are the same, and you know, this is a really good structure. So that happens in metals, okay, because metals, that's why they're so hard usually, or they're rigid. You flake off pieces of them, but they're when they tie to each other, they tie in a geometry that's tight, okay, that isn't as easily broken, because everything's tied to each other in a really easy way to keep exactly the same amount of pressure everywhere. So the pressure goes through the mechanism really easy. So that's why electricity moves through it easily, all that kind of stuff. But that's a whole, it's the same subject, but it's just a more complex version of it. But you can sort of get the idea that if this happens, this will inevitably create the opportunity for you to have a circumstance where, yeah, everything's all electrons on one end and all protons on the other end, in the sense that that's what's exposed to the world. So yes, internally it's more complicated, but what gets exposed to the world is something segregated, a black end and a red end. And that's what I intended to demonstrate with this little image. It's just you can keep making this bigger and bigger, and so that's why magnets, you can break them in half and you still have a magnet, because it just breaks on the right geometry. So it just breaks at points where this is where it would break, and so you'd have all red here and all black, and likewise. So it just breaks at the right places, and you end up with two magnets that are doing exactly the same thing the other two were doing, in the sense that they'll both be polarized the same way, black end down, red end up, and they'll just keep repeating that yeah, that arrangement. So the only thing left to point out is just the obvious, that once you have this understanding that this filter can be created, that you can arrange matter in a way where the force will leave in this segregated way. Once you accept that as a possibility, it doesn't require much imagination then to understand that when two magnets are facing each other with the same polarization, they're doing the same filtering at each other, you can understand that, well, this is just like the electrons not liking each other. This is all repulsive, and this is going to be all repulsive. So the more you bring these things together, you're going to force black stuff to see only black stuff. So you're converting black energy that came in this way into black energy that leaves this way, so to speak, and red energy that came in, say, this way, you're converting into red energy going this way, and this is automatically going to be repulsive. And the same thing's happening with the other magnet. So this is all repulsion, very strong repulsion, and that's why magnets are hard to push together when they're in that arrangement. But if you change the arrangement and make their poles opposite facing, you have exactly the opposite circumstance, where now everything coming out of this magnet is red, which this magnet just lets leave. So no pressure builds up, no reflections. So any force comes out of here, doesn't get reflected, can't go back and forth, it's not reflected, so it leaves. It goes out the relief valve, so you end up with a low pressure. And you can understand that the same thing's happening with the black magnet, is it's shooting black force at this other magnet, and black force just leaves, so no pressure builds up at all here, so you have extremely low pressure, and you still have all this external pressure pushing the magnets together, I mean the field energy pushing, and so you have less pressure maintained here, and so the two magnets are pulled right into each other because the external pressure becomes much stronger relative to the low pressure created in between them, because there's absolutely no repulsion, no reflections taking place. So it's all it's all low pressure. And yeah, that's the story essentially. Now I guess I could get into electrodynamics and why magnets move electroconductors and why they cause currents, or they cause electrons to move, but that's that probably should be a separate video, so I don't think I'll go into that. And again, this video is more for my own purposes, just to figure out how to best explain this, including enough necessary context where it can be understood that there's a nuclear mechanism that makes magnets work, and that the nuclear mechanism is related to the big picture function of the whole universe, and that all of this, all the stuff that happens, is happening with the same force. It's just that each manifestation of the force, from gravity to magnetism to light to the nuclear forces, each manifestation is functioning on a different level. Like the inverse square law is significant when it comes to the effect of gravity, because the motion towards each other can have a vector in any one of these directions. Any one of these directions, this pen is about dead, I guess, so put that one in the garbage pile. Any direction like this has a component that's this way. So in a sense, when the two things move towards each other, they're really absorbing force that was going this way. It was going a lot of different ways, and so when they radiate this low pressure, they radiate it to this entire sphere of the world. They don't radiate back and forth like electrons. They spill it to this whole 180 degrees of the half of the tennis ball. So it's 180 degrees both ways. So that's the inverse square law essentially. And so the gravity, in the sense that the low pressure created, the absence of energy, so to speak, because of the absorption of momentum, can be in any, it can, the point is it can zigzag its way to going in this direction. It doesn't go in this direction in a straight line. It goes in this direction by going a lot of directions that are just a little bit in this direction, and it absorbs all of that. And so when it creates low pressure, it creates it in all of these vectors. And so it doesn't matter where this thing is, it's going to feel the same low pressure no matter where it is on that 180 degree arc sphere, half of the sphere. And so that's the inverse square law. Now when electrons interact with each other, they're not spilling the low pressure in all directions. They're binary in the sense that they have a very they're living in a world that's dictated by very right angle kind of world. So these things are kind of operating in square geometry. You know, I mean, I drew them as circles, but they're sort of functioning as if the geometry was square, and the interactions are very direct. So there's no inverse square law. And so that's why they say something like, you know, gravity's a weak force by comparison to electricity or magnetism, is because electricity and magnetism aren't being spilled, you know, diluted by being spread as much as gravity is. Magnetism is still doing a over R in many cases in terms of its effects. So its effects is usually being spread over one dimension, 180 degrees, but it's always usually narrowed in the other dimension. So, and then the nuclear forces again are not spreading in both directions, so they're direct and straight across. So all the force impacts electrons and protons, all changes in force, where they're spill out, they're weakened by dilution in the other forces. And clearly the lack of segregation when it comes to gravity, the fact that the force isn't segregated, means it's going to be a weaker force. Alright, that should be enough for now. And like I said, I have to write this somehow, and that's the real point of this video, is to figure out how one goes through the process of going from the beginning to a sufficient amount of information to make it understood that this is a perfectly viable explanation for what's seen in the real world. Thank you very much.